Hi everyone, and welcome to our session today around the campus as a living lab. My name is Hannah Gapes, and I'm representing AWS from the Industry Solutions team. And my passion and focus is really around the education sector. We're really excited to have with us today Professor Stephen Wong from the Singapore Institute of Technology, and he'll be highlighting some of the success that SIT has had leveraging cloud technology. Now, before we dive into the presentation, we wanted to highlight a couple of points around our mission and our vision as an AWS education team. We see a world where education is personal, available, and lifelong for everyone. And in order to accelerate the digital transformation of education in partnership with the full community, we involve learners, we involve educators, researchers, and of course, technology providers. And AWS does this across the entire life cycle of the student learning life cycle. So this means from recruitment and admissions through to learner experience and right through to work and lifelong learning. So as you can see, it's a really exciting space for us. And on the board, we have a couple of examples of our capabilities and solutions in the education sector. So without further ado, I'd like to bring on board Professor Stephen Wong to share some of the success that they've had at SIT.
Thank you, Anna. Right, very good afternoon to everyone. Hopefully you all had a very enjoyable day today. I understand that this is the last session, if not close to the last session. So hopefully we can end it off with a bang. So let me introduce myself a bit. My name is Stephen. I come from a university called the Singapore Institute of Technology. In the university, what I look after is I look after several things, one of which is the digital competencies of all the students and the faculty in the university. That's one part of my job. Another part of my job, I'm also the director in my provost office, looking after several projects. Some of them interesting, some of them not so. So today I'm going to share one of the more interesting ones, all right, which to us, I'm also personally very excited about it, which is actually utilizing the campus as a living lab. So today's talk, because you actually see this when I'm talking about the campus as a living lab, in order to understand the significance that the cloud actually played in helping us orchestrate this platform. We have to understand where the university comes from, because we are a relatively new university. So I will spend a bit of time, not too long, to introduce a bit about the university, about our pedagogy, before coming to talk about what actually is the campus as a living lab. What are we aiming to do? What is the impact that the campus as a living lab will have, and the opportunities that it will give the students, the faculties, our industry collaborators. In a certain way, this is actually quite a rare chance. Later on, you will see. And in our mind, that's something that we can create a great impact in before going to where cloud comes in, because the cloud was a great enabler. Today, I will just share a bit about the data lake, about the data catalog, about the virtual campus, but it's not just that, because if I'm going to talk into every one of this individually, most probably we will have supper here as well. So without further ado, let me just dive straight into the presentation. So as I mentioned, I'm going to talk about these three agendas, brief introduction about SIT first. So let me just go into that, because I'm not too sure how many of you know about SIT. I understand we have some overseas visitors over here. No worries if you don't know about SIT. Hopefully after the next two slides, you'll see where we are coming from, because we are a very young university. But because we are very young as well, the way that we do things are a bit different. So, sorry, here we go. So actually, if you look at it formally, okay, we are actually a university that is less than 10 years old. All right, in 2014, we actually became autonomous universities. So if you look at it, it's a bit strange, because you look at the bottom of this, it says 2009. So if you look at it, why 2009? We actually have two birthdays. So SIT was actually formed 2009 to solve a particular problem. All right, the problem was, if you know the Singapore education landscape, a lot of the students after their O-levels will go to the polytechnics to take their diplomas. At that point of time, a lot of them, because there wasn't many university places in Singapore for them, they travel overseas. And what happens there is they take their degrees overseas, meet their boyfriend, girlfriends overseas, they stay there, and they don't come back. So with that, actually, the government started up SIT back in 2009. to really look at how we can keep some of these diploma graduates in the coast of Singapore. And in 2014, we turned autonomous, which means we gain the same rights as our fellow elder siblings, like the National University of Singapore, like Nanyang Technological University, like SMU, so on and so forth, to be able to confer degrees. Now, why I'm sharing this is because even though we are young, actually we have grown quite quickly. I mean, as of 2016, we are already the third largest intake among all the AUs, behind NTU and NUS. And one thing that is unique about what I just mentioned is that almost 90% or over 90% of our students come from the Polytechnic. And this is a key differential. The reason is, if you are aware of a Polytechnic education, these are actually students who, after their O-levels, go to take a diploma that is very focused on actually the skills and competencies for them to go out to work as a professional, as an engineer, as a software. So it's very vocational in certain ways. In this case, they are very hands-on because the whole point about diploma is really to get a job. And because we are a university that follows that trail, what you realize is that we are also very applied. So we actually pioneer applied learning in Singapore. So what is applied learning? So applied learning in a university standpoint is that like traditional universities, when a student, and you will hear this complaint quite a bit, in the traditional universities, when a student graduates, what happens? They'll say, oh, there's a steep learning curve to the industry. What I do in the classrooms, especially if you are in engineering or in ICT, what I do in the classrooms is very detached from what the industry is doing. Very often you'll realize in certain universities, the same textbook I have taken, okay, I have used in my undergraduate years, maybe the same textbook that my children will be using, all right? So there's a big gap between what is in the industry versus what is actually taught in the university. So for us, applied learning means what? Means that our whole goal for our students is when they graduate, they go out into the industry as working professionals. We minimize the gap between what they learn and what is actual. All right, with that in mind, now that we have seen that, the whole point is how then we make the learning of our students authentic. And that's where I have to talk a bit about the campus, and because that is the beginning of the Living Lab. All right, so if you look at this, you ask, okay, so SIT is a new university. For those who live in Singapore, when you travel around the expressways, you'll always see the SIT logo somewhere, right? And you ask, so where on earth is the campus of SIT? Okay, at this moment, I will say that we are one of the most distributed autonomous university in Singapore. We cover north, south, east, west, central, everywhere. We are going to lose that status very soon. So right now, if you travel nearly, let's say you travel along AYE, you will see our logo because we have a building in Singapore Poly. If you go down, let's say, PIE, you will see one of our logos as well because we have a building as well down at Temasek Poly. So we actually have one building in every polytechnic, and then our HQ is at Dover. Now, very soon we'll lose that status as the most distributed autonomous university in Singapore because we are going to have a new campus in 2024. All right, I'm not too sure how many locals are here that stays in Punggol. Something exciting is coming to Punggol, and you will see what we are trying to do there, as well as later on how the cloud has enabled us to actually create the architecture before we even move there. Right, so the new campus in Punggol is really very exciting for us because if you know Singapore, Singapore is a very small place. Lands is very scarce and very valuable. In order for a university to get a plot of land to really develop our campus, it's actually Christmas gift came very, very, very early. All right, I'm not too sure whether there will be another university that has this opportunity, but for us, this is really a rare opportunity to really look at things differently. So we had several things that we can do. We can build the new campus like all other campuses that you might see in the world for universities. If I was to blindfold you, bring you into one estate, unblindfold you and tell you, can you tell me whether is this a university or is this an industry company? Sometimes you can't tell. All right, the reason is because all buildings are used the same. All right, in a university setting, traditionally, the buildings or the campus is used to house the learning and to house the experiments. All right, it's not used for the experiments or not used for the learning, which is something that we want to change. Why? Because for us, it's a very unique opportunity that we have in Punggol. So Punggol is designated as a strategy to build up our digital innovations, digital solutioning and showcasing, all right? So it's called the Punggol Digital District. And the thing about the Punggol Digital District is that at the heart of the Punggol Digital District, you have SIT, which is a university. Surrounding the university, we have Industry Park, which is called, that is managed by JTC, our Jurong Town Corporation. And beyond that, we have something called the HDBs, which is the residential estates. So if you look at it at the ecosystem point of view, this is very interesting because you have the education institution in the center as a heart, surrounded by the industry and surrounded by the community. So this gives us a very unique opportunity to actually work with the industry on innovations, on new, on co-development, or even some of their existing products to showcase to the community. And together, this really can support the whole ecosystem as a smart nation in Singapore beyond just 2023. Okay, so the upcoming Punggol campus, you can see a very nice photo there. I hope my office will be one of those that is at the window viewing the coast. It's a very nice campus. We are one of the few waterfront campuses in Singapore. I think we are the only one, if I'm not wrong. So nice views, but what is incredible about this campus is that we have a lot of sensors with the new digitalization. We have 20,000 sensors around the campuses. We have a cool IT systems that support the entire operation of the campus. We have a district cooling system that supports all our cooling requirements, as well as we actually have our own microgrid that we are able to actually power the campus using our own solar systems and our energy storage systems. Now, with all this, then came a thought. Just now I mentioned, we can build this like a traditional campus. All right, so like any other university, let's say, I say you now have a new campus. I can go and design it, create labs, create auditoriums, create lecture theaters, create tutorial rooms, and just house the learning. That's what many people do. All right, and ultimately, if you look at it, the campus is just there to house the learning. You can do your learning anywhere else. You can move the campus. It doesn't matter, really. I mean, and what they usually do is make it very nice. But for us, because this is really such a rare opportunity for us to have a campus, and also it's a rare opportunity to have such an ecosystem where we have a campus, a university as a heart, and the industry as well as the community, we decided to do the campus as a living lab. Now, some of you may have heard the word living lab before. Some of you may not, but just to clarify it or to synchronize the meanings, because it means different things to different people. So in the education sector, like SIT, okay, traditionally what has been done is that I'm pretty sure some of you here will have gone through your degree programs, especially if you're in engineering or you're in IT. When you study, your lecturer will do exactly what I'm doing now, stand on the stage and just do a monologue, right? Then after that, you will be led to a lab sometimes, and then you will go there and do your experiments. And what you discover about those experiments, they are a very controlled environment. Okay, they are actually not the real environment. For example, we are talking about energy grids. You are working off a small portion of an energy grid or just a subcomponent. You actually don't touch the real thing at all. So in a traditional lab, what it looks like is we bring the real environment and then we emulate that in a lab. And then the students, the faculty, then do their experiments there. They do their research there, they do their innovations there. What you realize here, as I mentioned very early on about SIT, we are a very applied university. Our whole point is how do we make this as real, as authentic a learning and research experience as possible. So for us, we want to reverse this. Rather than let the campus just house the learning, the research activities, why not reverse it? Use the campus, all right, as a resource to carry out the applied learning as well as the applied research. So back to just now's example. Instead of doing things in a lab environment, is there opportunities for us, for the students, to toy around and play around with the real operating systems that's running around the campus? Okay, those can go from, let's say, cooling systems to electrical systems, right, to even the IT systems, the building management systems. So make those as a resource because those are very valuable. And from an industry point of view, later on you will see as well, as a living lab, it allows the industry to bring in your products, your solutions, or your problem statements into a real-life environment where the students, the faculty, and the industry can co-work and co-develop together. So really, for CORE, is really to integrate the education, the innovation, the applied research for whole stakeholders, academia, industry, government, and community, so that Singapore is a hub for innovation and talent development. Now, just to give you all an idea what this means, okay, because actually if you look at it, Punggol is still 2024. Okay, the whole concept that we have leveraging off the campus as a living lab is we have the physical campus, okay? We want to enable part of the campus, or actually all of the campus, to be used for students to experiment with, for industry partners to come in. So for example, today, if I was a industry partner doing climate control, all right? I want to try out a new climate control system that can actually optimize the comfort of the people in the room as well as save energy, all right? So we can be working with them and saying that, okay, can we do this and put this into one of our buildings, one of our rooms, so on and so forth. So that's the physical living lab. So we can allow innovations to happen, or we can allow integration of our collaborators' solutions into our systems. And then from there, because it's running, these are real life systems that is being used, which means real people go to these places. They are being used by students, by faculty, by visitors, right? So through this, we collect the data. So we look at it, okay, based on the data we collected, how is the room comfort, how is the energy that is being used, so on and so forth, because traffic is real life, right? And from there, what we can do is, so that is the data collection, we can simulate. Now we can create digital twins, models, to see actually how would it be like if the room, for example, this room was totally crowded. Okay, what would the comfort be like? How quick would the aircon be able to respond? Then what can happen is, because these are all real life data, we can get students to work out several models, see which model competes and work the best, right? And for the models that actually work, or the algorithms, or the solutions that work, we can then say, hey, is there a way we can now bring this into the real environment? So for example, you can imagine today at this hall, okay, if this was a living lab, okay, and all of you are students, okay, yeah. So you can imagine, you all can be all working on an algorithm to actually manipulate the air conditioning here, right, on a digital twin, test out different type of algorithms to see which one gives the balance between energy consumption and comfort. And the winner of that, what we will do is, I can say, okay, then for the next hour, I'll implement our algorithm into the real system. That's where we call the actuation and emulation, because that's where you collect the real data. And then you run your algorithm, you collect the real data, do the deployment, and then you can actually optimize your system. So what you realize here, when we are doing this in the university, just this example, the algorithms becomes real. It gets implemented, it's in a real life environment. The translation to market, okay, the realism of it is real. So that's what we mean by authentic learning experience. Right, so for the students and the faculties, really, I think for the campus as a living lab, it facilitates real-world problems from the industry to be solved in partnership with the industry. It allows the graduates actually to help the industry as well as talents, all right, to develop innovations, solutions in a real-life environment. And of course, for the industry, this is great because for the small businesses, SMEs, big companies, usually you can say, oh, I have my own building. I can create my own building as a living lab. But you think about the small businesses. If today I was going to build a new image recognition algorithm, okay, or product that maybe use cloud for processing the imagery and recognizing people, but I want to try it in a real-life environment. For me, it would be difficult because as a small SME, there's no way for me to put this, correct? I mean, I don't have my own building. But that's where we can actually work with them to say, hey, can we offer you the campus as a test bed, as a service? So you put your device into our campus, we have a research collaboration agreement, we have understanding of what that is supposed to do, and then you can work with our faculty, our students, to co-develop your solutions or to finalize your solution, optimize your solutions. So that's when it's a win-win-win situation. For the companies, they now have a test bed that is humongous, which they would not be able to afford by themselves. For the students, they get the experience to co-innovate with the industry, right? And in a certain ways, all parties wins. And for the small companies as well, they can then make use of this opportunity to go out to the region as a showcase, because now you have a real environment. You can showcase these things runs on the campus, right? And of course, that will bring us much closer to our vision, okay, as a smart nation in Singapore, right? And as I mentioned just now, in PDD, SIT is surrounded by the community. So this is also a very good place where almost half of our campus is actually publicly accessible in Punggol. So the community can be walking around our campus and looking at all these solutions that the companies and the students and the faculty co-innovate, co-develop together. So for us, this is a great, great opportunity. And one of the examples that I think was recently mentioned in Straits Times was Singapore to house the largest private microgrid in our SIT campus. In the past, when we do this, okay, you would just look at one perspective and say, okay, we house the microgrid. Good, okay, so we save some energy. Instead of buying energy from an energy supplier, we make use of green energy from our solar panels up on the roof, all right? From operations point of view, that could be it, right? But what we decided to do last year actually was we decided to say, hey, look, rather than using it just as a microgrid to supply energy, following the Living Lab strategy, can we now actually expand on this and actually explore how we can actually create the energy grid as a living lab as well? So that's what we call Energy Living Lab. So we actually split our whole grid so that now, that's why you see down there the terms, we have the pico grid, the nano grids. So what happens is rather than just one entire big microgrid that supports the entire campus, okay, if something fails, everything fails, we have actually redesigned the entire microgrid so that now we have things called pico grids, which are working at riser level. So anything fails, it's just a riser. So now you can have concurrent experiments running. Okay, we also have nano grids, which is at building level. So I can also isolate buildings to do experiment, or I can run across the entire campus as a microgrid. So this is something that's very interesting for us. Okay, where does cloud come in later on, you'll see when we're talking about the experiments. Okay, because you can see that there's a lot of things. Microgrid is just one of them. Okay, and actual fact, the complexity or how huge this thing might be, all right, is something that we actually have a sense and feel of it already. Because as I mentioned, we are one of the very few fortunate universities, to have a future campus, nice waterfront campus up in Punggol, but we are also one of the universities that actually have already existing campuses, which we can experiment on. And, and to me, this is fantastic because at one of our campuses, current campus at NYP, where I'm based, we want to create that as a living lab because if you look at what I was speaking just now about living labs, to make that work is actually not a trivial process. Okay, you can imagine in a estate that you own, all right, you have a lot of people with different agendas, with different partners, with different projects, all running within the same space. Okay, some of them might be even competitors. So you may have two competitors running in your campus, both developing their innovations. How do you mitigate against that? So there are a lot of issues that we need to resolve. And the good news for us is because we have existing campus, which is why we actually want to we actually converted our campus at NYP, okay, into a living lab to try out some of the solutions, what works as an architecture, because it's not as straightforward to say, oh, I just want to install, for example, this, I want to have the students able to control the climate. It's not that straightforward because you can tell if anything goes wrong, all of us will most probably be sweating, okay, at this moment. So how do you mitigate against all that? It's actually quite complex. So we already started doing some experiments over at NYP, okay, trying out the Energy Living Lab. We do have a little microgrid up at NYP. We call it a pico grid that we are working on with some industry partners, essentially looking at AC-DC hybrid devices. We also envisage in the future campus, we will have robots running all over the place. So from service robotics to security robots to automation to telepresence. So we are also looking at actually using the robots to automatically scan, do a scan of our environment so that we can actually create a virtual model of it. Of course, as a living lab, the good thing is we can do cybersecurity. And this time around, cybersecurity is very real because it's not only in the lab environment, it's actually really in the real operating environment where you have a lot of noise and a lot of different things that's coming into play. And we are also trying out blockchain. So you can see there are many activities that's happening, okay, which is where I want to talk about the cloud, all right? Where do the cloud comes in, all right? So if you look at this, the opportunity that presents to SIT in our future campus is I now have a great place where I can try so many different experiments. I have so many sensors, so many partners, so many whatever that's all over the place. You will start to realize it's a very complex system, correct? You have many, just students alone, we have more than 10,000 students in the future. Okay, we have a huge community that's surrounding us that will be walking in and out of the campus. We will have most probably hundreds, if not thousands, of industry collaborators. Not only that, we also have overseas collaborators. All right, so we have tons of data, tons of equipment, tons of solutions, tons of projects that's running around. Okay, which is why for us, we need to build an operating system for the living lab. All right, because if you look at this, one of our thoughts is we want the living lab to really allow testing of third-party solutions innovations while minimizing the risk for campus operations. All right, you look at this, Actually, universities are a very good place to do experimentations, even like this, because you can imagine if we are working in a real industry, in a real industry estate, okay, where you are paying rental, and the energy goes off. What will happen? Most probably, all the tenants will complain, right? Whoever who is the owner of that property, most probably will have several lawsuits to come. What happens when we do experiments, even at the building level in the university? Today, the energy shut down, the building goes down. I just stand on the stage, I tell my students, okay, we ran out of energy, okay, lessons is cancelled. Instead of sadness, you get joy. So university is a very good place actually to do all these type of experimentations, but we must be able to support it with an operating system like this. So let me just explain this very busy diagram a bit. Then you see where the different parts are. As said, we want to enable our campus to be utilized as a real-life test-bedding environment. So if you look at it, that's the things at the bottom. We actually have campus operations that's like any other campus operations. Okay, you have the IBMS systems, you have your microgrid, DCS controllers, you have all your sensors and so on and so forth. This is kind of business as usual, but where do we want to really create a difference? Because we say we want to make it a living lab. But you also cannot negate the fact that you have 10,000 people running around the campus in Leh every day. You need campus operations to be able to carry on. So how do you mitigate between the risk of things failing versus the desire to do experimentations, which is where we came out with the Living Lab network, the Living Lab operating system, which is the one up there, all right? So internally, what happens, we want a way for us to interconnect actually external devices within our facilities. So we have something called a Living Lab network, which is a physical network that actually is different from our campus network or corporate network. It's really a network to do applied research, innovation, applied learning with the industry, all right, where actually industry can come in and put in their products, utilize that network so that students can actually do some experimentation on. And what can happen there is, because of this, the controls that they can have, okay, for example, for this diagram, we're actually working with a microclimate control company that wants to test out their solutions within one of our buildings. That's why you see the building W1 there. W1 is actually one of our buildings in the future campus. Now, the interesting thing is what? They have their own appliances, hardware appliances, to monitor the thermal comfort or the conditions of the rooms. All right, so they have that, which we then install into our Living Lab network. All right, they will have a lot of data coming from that. Okay, so rather than them accessing the data directly, which may not benefit our students, because end of the day, this data are very rich. Okay, what we do is that we want the data to go into a data lake, right? So that other students or other faculties can take a look at this data and maybe do optimization on it. Okay, but back to this company. So what happens is they want to install their sensors, but they also want to take over the climate cooling of the cooling of the building W1. So how do we do that? That's where the Living Lab operating system comes in. So their control systems are actually out on the cloud. So what they do is, from their appliances, okay, they can actually monitor what is happening in the room, send it all up to the cloud. The cloud will do the processing and say what is the optimal energy to utilize, okay, and then send it back in again. Okay, this is where it's very interesting because having the data allows us to actually create digital twins that we can actually build and actually try to see what happens when we want to do this, for example, students to actually work on certain algorithms that we can then propose to the company and say, hey, can you put this algorithm into your solution and see how it actually runs? Okay, so in certain ways, we can actually co-develop with the companies the cooling solutions, okay, based on their control systems. But the other thing is what happens if this company, something went wrong? Okay, this company's systems got hacked, for example, or there's something wrong with the research, or something wrong with the systems. We must be able to gain back control of this building W1, which is why this system is very cute, because if you look at that lock over there where you see W1, we have the ability to cut off the external systems as well, and then revert back to our own original state, okay, which means that we have resiliency within our operating systems. Okay, as mentioned, we do have tons of data because our Living Lab covers all publicly accessible spaces in our future campus. So if you are collaborators out there, you feel that there's something interesting that you can do with us in our future campus, you can put things in. Okay, of course, there must be a benefit to the students, to the faculties, and to yourselves, right? But you can tell just our campus operations alone, we have tons of data. With all the other appliances within the whole network, we have even more data. So how do we do to arrange this data? Okay, because different data sets will be used by different people for different purposes. Okay, which is where we came to talk about the data lake. And this is important because if you look at the way of creating this infrastructure in the past, right? So let's say we are now 20 years ago, all right? I'm creating this architecture for my campus, all right, which is going to be built a few years later. Imagine we don't have cloud. Okay, I share with you what is the issue now. The issue now is if I want to support the Living Lab operating system, that architecture, I have massive amount of data that's going to come into my system. Today, if I'm building the campus, this without cloud, I have to think about how much on-prem resources I need to put, how many server rooms do I need to actually host all this data, how much people will I actually have utilizing all this, right? And actually, a lot of time, I can't even build anything now. I must wait until it's developed. I have my data center, then I can start building my solution on top of it. Because it's an issue. You see, as we scale along with the campus, we have more and more collaborators, more and more systems that will come, right? We will have to make, if this was an on-prem system, we have an issue. It's very difficult for me today to predict how many partners will come, how much data will they bring, okay? And this data, how long are they going to use it for? Is this going to be something that we need to store for an indefinite time? Even if they have the data, let's say this very interesting data set, how many users are going to use that data? So to us, this is a big issue, okay, which will be very difficult to resolve before the invention of cloud. But with cloud, it's slightly different. So with cloud, what we can do is the scalability is no longer my concern now because it's no longer in my CapEx. It's an OpEx problem, correct? And OpEx problem can be solved. Why? Because when collaborators come, they can co-fund, right? Or we can get grants together. It's something that we can solve later. And I don't need to answer that question of, oh, you just bought a server. You just bought X amount of storage. What is your utilization, correct? Because if it's on-prem, I have to do a forecast. That forecast is going to be difficult and challenging to do. So in certain ways, that's something that I think the cloud has allowed me to do, not think about that problem, just design it in such a way that in the future, if I need more, I just get more S3 buckets. I need to put things in Glacier, I put things in Glacier. So I just pay. And I can always get, the business model is also much more flexible. I can always work with the collaborators to do it as I said, testbed as a service. So that was a great thing. Now, that's one. So in terms of the scalability, the cloud really gave us that ability not to think about the problem today when the campus is in 2024. Now, the next thing that it allows me to do actually is really from the development side of the house. Okay, if you all know data lakes, what data lakes are, essentially they are a whole collection of data, raw data, structured, unstructured, that all comes in from many, many different places. The issue with this is that if you want to build a data lake, catalog them, do all your ETL and stuff, in the past, if we are doing this from scratch, I can share, even though the campus is 2024, today I start software development. Most probably by the time the campus becomes old, I will still be doing the development, okay, because you start from scratch. Right, the good thing about cloud and about what we are doing with AWS as well is that if you look at this diagram over here for the data lake, you will see a lot of nice symbols. For those who know these symbols like Athena, Glue, so on and so forth, these are actually Amazon microservices, correct? So these are actually built. They are there. It's a service that we can just turn on, architect together, and immediately pop, you have it, a data lake, correct? So it's a very quick way. Actually, the whole development of this, still took us a bit of time because it's our first time building a data lake. It took us about 6 months to build, but I can share as a software engineer, if you ask me to do this from scratch without cloud, most probably, it will not be 6 months. I'm not too sure whether 6 years I'll get it done. So this is something that allows us, and it's very flexible in a way that if today I get the design wrong, it's okay. Okay, I just take away one of the modules, plug another module in, and I can try it again. Right, so this allows us to actually create this data lake very, very quickly. And if you look at just now the architecture that I was talking about, it's actually very complex because you have a whole variation of different sensors, different systems that's going to be integrated into the campus. How do you actually manage that? So there must be different sources of data that's coming in. So if you look at the ingression point of view, the data producer point of view, you can see that actually there are already services we can leverage off from AWS that actually manage for us to actually test bed this. Likewise for the utilization of the data. The good thing about this is because there's a lot of data analytics tools as well that's readily available to the students, to the faculty. They're all there on cloud. So today, I don't need to go and prescribe to a very expensive license that, for all you might know, become a white elephant one student use. Okay, it cost me hundreds and thousands of dollars. We can just leverage on what is there, and there's a lot of services up there. So, and in actual fact, I don't even know all of them. So the students might know better than me. So once we have this leveraging of the cloud, not only can I structure a data lake, but what I can do as well is to utilize the tools that is on it for the students to actually play around with the data, do their analysis. They can even come up with AI and so on and so forth. But that being said, okay, the cloud do enable a lot of things. There are still many things that we need to manage within the data lake, of which one of those that if you are going to formate your own data lake for whatever reasons, you have to think about. Okay, when you come up with this, you have tons and tons of data in your enterprise, in our case, in our campus. How do you organize the data? How do you know what data is available? How do you know who accesses what data? How do you know what access is given to who? How do you control all this? Which is why it's very important when you are doing all this. Another thing that leveraging of the cloud solutions gave us was the ability to build a data catalog very, very quickly. All right? So a data catalog is essential. Because without a catalog, you can imagine in our situation where I have a living lab, I have tons of devices coming into the campus. All right? I will have actually a lot of collaborators that are using the data. They might be collaborating with us this year, they might not next year. We have new collaborators coming. How do I manage all this information? How do I let them know what is there, what is available? All right? So that is where actually formatting the data catalog is very important. And again, this is something that we can build very, very quickly, and we did build very, very quickly on the cloud, so that we can have our data custodians, people who are helping us format the system. They can build that very, very quickly. How do they onboard the data? How do they actually classify the data, put them into the data catalog? And what is good here is, from a data administrator or a data steward's point of view, these data sets may belong to me, all right? They are the data sets that I can administer. I can now use the data catalog to say who do I give permissions to. I do not need to memorize them. And once you give permission to them, back end, you can actually then get the data catalog to talk to the data lake to give them a grant them access. So this is very, very comfortable for us because from a user perspective, this is very seamless. Okay, in the past, you have to send emails here and emails there asking for, can I have permission? Then you have permission today, you leave the organization, you take all the data with you. Here, trackability, traceability becomes very easy via the data catalog, right? And not only that, actually, because our future campus is still 2 years away, so what we want to do as well is, hey, can we utilize all this data actually to materialize some of the concepts we're speaking about, okay, before even we move into the future campus. Just now I did talk about the digital twin, so we are in the process of actually developing a virtual campus as well. I will leave that for another talk, maybe AWS Summit next year. It's very interesting as well. We can today come up with campuses like this, run it on your EC2 instances without heavy investment. It's actually quite a nice thing to do. So what we want to do as a next step is really how we integrate the data lake to the virtual campus even before we move to Punggol. So this allows us actually a great flexibility to showcase, even before we move there, a lot of the thoughts that we might have and things that we might want to do. Right, so this one, stay tuned. Okay, I think we are going to have more of this. Hopefully, we will get some examples up soon as well. Okay, because I'm mindful of time, so I need to hand back the stage to Hannah to close off today's session. So thank you all so much. If you have any questions at all, okay, or you want to explore some collaborations, do feel free to email me. My email is up there. All right, so thank you all so much, and I hope you all have a nice day. Okay, Hannah, back to you.
Thank you very much, Professor Wong, for sharing with us how SIT is transforming the campus experience. Before we close, we'd just like to remind you of 2 resources we have available, and we encourage you to scan these QR codes. So we've got the AWS Skill Builder and the AWS certifications. So please do make use of these resources. Thank you again, Stephen. Our contact details are here up on the slide if you'd like to get in touch. We'd love to hear from you, so look forward to speaking soon.